Alrighty, welcome back. Yesterday we did multiplying, so you can imagine today we would do dividing. So that's what we're going to do, dividing radicals. Alright, and then of course simplifying. So just like with multiplying, if we have the division of A over B, then of course this is radical A over radical B. So you have an example, we have a fraction. So what you always want to look for, first of all, can it be simplified right away? Well, yes, this can, because we know the square root of 25 is 5, the square root of 9 is 3, and we're done. Yay, don't you hope for those kind of problems. Here's another one. The square root of 1 would be 1, the square root of 16 would be 4. Pretty simple, right? All right, so it's so simple. You get to try example 3. Wait a minute, before I get ahead of myself. Example 3, we have 18 over 50. Okay, now this is still under the radical. Now these are not perfect squares. However, I could reduce this fraction, and you should try to do that. Does everybody see that 18 could be divided by 2, and so could 50? Right? So if I did that, if I wrote this as 9 by 2 over 25 by 2, doesn't 2 over 2 cancel? It's like reducing the fraction. So radical 9 is equal to 3, and radical 25 is 5. So this one actually reduced to 3/5. All right? So now you get to try the practice. I'll put the answers up. Remember, if they're perfect squares, pull them out. If they can be reduced, do so. And then simplify as you're able. So stop the tape. You need to do these yourselves. So A, B, and C were pretty simple. They just came right out from the radical. Now these I want to simplify. I want to reduce. Okay, so I'm reducing this to 9/16. Those are both perfect squares. So 3/4 comes out. Okay, now this big old honking number, I'm going to cross out the zeros. Oh, square root of 225, that's 15. Square root of 256, 16. Done. Yay, yay. All right, the next thing that can happen is like in example 4. All right, in this one, you've got radical 27 over radical 3. Well, doesn't 3 go into 27? Sure. And as long as they're both under the radical, that's fine. So 3 goes into 27, still under the radical 9, and so the square root of 9 is 3. Now be aware, you can't do something like this. You can't take an integer into a radical. So don't be tempted to sin and go to math jail, okay? All right. So let's do another example. That's example 5. We've got, I need a pen. Radical 30, a to the third, over 6, a to the second. Okay, well, how does this simplify? Well, 6 will go into 30. They're both under the radical. That's cool. So 6 goes into 30, gives me 5. A squared will go into a cubed and give me a, won't it? And another way I can think of that is when I'm dividing with exponents, I subtract. And remember, these are still under the radical, so everything's kosher. And this then would be my final answer. All right, let's do F and G. Again, please turn off the video for a moment, do them, and then come back and check. So F, hopefully you saw that 2 goes into 50, 25, and the radical 25 is 5. For G, all right, we have radicals here. 7 into 42 is 6. This is under the radical. X to the fourth over x to the second is x to the second. And so I should simplify this. The radical 6 cannot come out, but the x can. Okay, so radical 6x is your final answer. Okay, and it doesn't matter the order. I tend to write my radicals first, but either way is fine. Now, the next part of this lesson is, we taught you how to divide, but there's this funky thing that you're not allowed to do, which is leaving a radical in the denominator. So what we have to do is something we call rationalize the denominator. And it's pretty simple. So when you are simplifying, working on these, and say that you get to this point where this is your answer, okay, you can't leave a radical in the denominator. Just a law, okay? So we want to then multiply this fraction by a form of 1 that will change appearance but not the value and allow us to not have a radical here. Well, think about it. What could I multiply radical 3 by to get an integer to come out? Well, couldn't I multiply it by radical 3? Radical 3 times radical 3 would be 3, wouldn't it? Radical 9 is 3. So if I multiply by 1, I'd have to multiply in this form. This is 1, right? Anything over itself? So we got our denominator. What's our numerator? Radical 6. So this, gang, is our final answer. Now again, don't be tempted to put the integer into a radical. Very different. If you punch this into your calculator, ain't no way this is going to be 2. All right? You can't have radical 6 divided by 3 and get square root of 2 or 2. Doesn't happen. So this is our final answer. And why again? Because we're not allowed to leave radicals in the denominator. So we're going to multiply by 1 in a form that will allow it to come out as an integer. All right, so let me do another one. Make sure we got this. All right, we've got 6 over square root of 2. All right, you cannot take the 2 into the 6. This is a square root, okay? But I can't leave that with a denominator that has a radical in it. So I'm going to multiply by 1 in what form? What do you think? Oh, I hear someone say radical 2 over radical 2. Okay. So what's the denominator? 2. The numerator? 6 radical 2. Now, can I reduce parts of this? It's a product. And 6 over 2 could reduce, couldn't it? All right, so do that. You can reduce that part. Those are both integers. And these are factors. It's not part of a sum or a difference. If this said 6 plus radical 2, I couldn't do that. But since it's times, I may reduce the 6 halves and make it 3 radical 2. Okay? And then the example 8, we have radical 5 over radical x. Oh my, now that they're throwing letters. Well, that's okay. We're going to follow the same principles. I don't want a radical in the denominator. So I'm going to multiply by radical x. That'll give me x, won't it? Yeah, any radical times itself will give you the radicand, the thing underneath the radical. All right, so I have to multiply by the same thing. This is 1. So radical 5 times radical x is radical 5x. And don't try to reduce right there. Okay, let's try h, I, and j. So on H, hopefully you knew what to do here. Pretty simple one. On I, we multiplied by radical 6 over radical 6. You got 8 radical 6 over 6. This 8/6 can reduce to 4/3. So this is our final answer. And on J, we have radical xy over y. You cannot take the y into the radical y. So we're done there. All right, just a few more. Next example, we have radical 3/4. And so as you see, that is like saying radical 3 over radical 4. So we really don't have to rationalize because that comes out. Does everybody see that? Radical 4 is 2. It's rational, so it's good. We don't have to do anything there. Okay, example 10, we have radical 5 over 12. So what you might want to do is realize that 12 is 4 times 3, isn't it? So the square root of 4 is a 2, radical 3 is underneath. So when I rationalize, I'm going to multiply by radical 3 over radical 3. This gives me radical 15. Okay, now the radical 3 times radical 3 is 3, times the 2 that's there gives me a 6. Now, if you do it this way, you didn't simplify and you went ahead and multiplied by radical 12. That's okay, it's just going to give you a little more work. You're going to have radical 60 over 12. Now, radical 60 has a perfect square factor. It is 4 times 15. So radical 4 is 2 radical 15 over the 12. And 2/12 reduces then to 1/6. So you have radical 15 over 6. So it doesn't matter which way you do it. I like to simplify and work with my littler numbers so at the end it's already reduced. But if you do it this way, it's fine. Just keep asking yourself, can I simplify? Can I cancel? And don't cancel in the wrong spots. Okay, so let's do the practice or the try this K through P. I'll put these up and you'll be ready to do your assignment. You all can skip O and P. We're not going to do anything past there. So just do K through N. All right, so I kind of did them both ways. This one we rationalized. That's pretty simple. This one, I went ahead and simplified my radical 8 to 2 radical 2. Remember, this is 4 times 2, so square root of 4 comes out. Radical 2 stays in. Then I multiplied by 1 in this form, radical 2 over 2. So radical 10, this right here is 2 times the 2 that's here. That's how I got the 4. This one, I didn't simplify. I went ahead and multiplied by radical 27 over radical 27. That's my 1. So 27 comes out. This product is 54, which is also 9 times 6. So the square root of 9 is 3 radical 6 over 27. And 3 over 27 reduces to an implied 1/9. So this is our final. All right, and down here, we just multiplied by 2a, so 10a, and 2a comes out. All right, we're not going to do O and P. So refer to RenWeb for your assignment. Have a wonderful afternoon.